All right, here we're going to look at 1987 AB1, and this is a particle motion problem as well. This particle motion problem is going to give you the acceleration to begin with. It gives you the acceleration is 6t minus 18. And we're going to have to work backwards to find the velocity and position functions. Part A asks us to find the expression for the velocity v of t of the particle at any time. So we know that the integral of acceleration is velocity. So what we're going to have to do for part A is we're going to have to take a of t, the acceleration, which we just said was 6t minus 18. So 6t minus 18, and we're going to have to integrate that with respect to t. So if we take the integral of the acceleration, we are going to get the velocity formula. And when we integrate 6t, we're going to have, we raise our exponent 1, which is going to give us t squared, and then we divide out front by that 2. So 6 divided by 2 is 3. And then we'll just have a minus 18t here for this term. And then we always need to remember to put our constant of integration there, so we have plus c. Now we can't leave it like this with the plus c. The problem gave us information that we need to plug in so we can find that c value. If you look back at the problem, it says at time t equals 0, the velocity of the particle is v of 0 equals 24. So we know velocity is 24 whenever we plug in 0. So if we plug in 0 for our t and 24 for our velocity here, we see we're going to get 24 equals c. So our velocity function is going to be v of t equals 3t squared minus 18t plus 24. So that is the equation that we're going to get for our velocity. Then if we look at part B, it's going to ask us for what values of t is the particle at rest. Well, the particle is going to be at rest if the velocity is 0, so we need to find the places where the velocity is 0. So we're going to take our velocity function, here. V of t equals 3t squared minus 18t plus 24. And we're going to set that equal to 0. I'm going to factor a 3 out here just to make our numbers a little easier to deal with. We're going to have 6t plus 8 whenever we do that. And then we're going to factor t minus 4 and t minus 2. So our 2 points that we get here are t equals 2 and t equals 4. So the particle is at rest at t equals 2 and t equals 4 because its velocity is 0 at these 2 points. Okay, so that answers part B for us. If we go back and look at part C is going to ask us for the position formula. So to find the position formula, we have to integrate the velocity function. So we are going to begin with that velocity function that we've been using, v of t equals 3t squared minus 18t plus 24, and we are going to integrate that with respect to t. So the integral of velocity is going to give us position. I'm going to use x of t for that. And then when we integrate 3t squared minus 18t plus 24, here we're going to have t to the third. We have to divide that 3 by 3, which just gives us a 1 that we're not going to write here. Then we're going to have a t squared. 18 divided by 2 is 9. We'll have a plus 24t. And don't forget to put your plus c, that constant of integration, there on the end. So in this case, we also need to find that constant of integration, that c value. So let's look back at the problem to see what information we can plug in. So if we look back at the problem, it tells us its position is x of 1 equals 20. So whenever our time is 1, the position is 20. So we're going to plug in 20 for the position here, and 1 for all of the t's that we see in the function. Let's make that a 1 here. So 20 equals 1 minus 9 plus 24 plus c. So if we have 24, we got to subtract 9, add 1. We're going to get 16. So 20 equals 16 plus c. We want to subtract that 16. We're going to get 4 for our c. So our position function is t to the third minus 9t squared plus 24t plus 4. And that's our position function that we're given there. So, our last part is part D here. And part D says find the total distance traveled by the particle from t equals 1 to t equals 3. Now, we know that in this case we definitely need to know the position at t equals 1 and t equals 3, but we also need to know whether the particle changed direction between 1 and 3. So if we look back at part B where we were dealing with velocity, notice that we set velocity equal to 0 here. And the velocity is 0 at 4 and at 2. This in particular is a critical point, and this in particular matters to us because it is on the interval 1, 3. So if we look at what is going to happen here, if it changed direction, it had to change direction at t equals 2. So we want to find x of 0. So we will have 0 to the third minus 9 times the, oh, I'm sorry, we don't need x of 0. We need x of 1. We're looking on the interval from 1 to 3, not 0 to 3. So we need x of 1, which is going to be 1 to the third minus 9 times 1 squared plus 24 times 1 plus 4, which is going to be 1 minus 9 plus 24 plus 4. So see, this is 28. We subtract. Let's see, 1 minus 9 is going to be negative 8. So whenever we add these together, we are going to get 20. So x of 1 is 20. The position whenever time equals 1 is 20. We actually didn't even have to do that because it gave it to us earlier in the problem, and I should have remembered that. We need to find x of 2. So 2 to the third minus 9 times 2 squared plus 24 times 2 plus 4 is going to be 2 to the third is 8 minus 9 times 4, which is going to give us 36, plus 48 plus 4. So here we've got 8 minus 36, which is going to give us negative 28. We add 48 plus 4, so this is going to give us 20 plus 4. So x of 2 is 24, so the particle moved to the right 4 units here. And then we need to find x of 3. So 3 to the third minus 9 times 3 squared plus 24 times 3 plus 4. So we're going to get 27 minus 9 times 9, which is 81, plus 3 times 24, which is going to give us 72, plus 4. So here, if we put the negative 81 and the 72 together, that is going to give us negative 9. So we got 27 minus 9 plus 4. 27 minus 9 is going to be 18 plus 4. And we'll get 22. So x of 3 is 22. So in this case, the particle moved 2 to the left. So if we add those together, total distance traveled is going to be 6 units.